Here I plan to demonstrate cross-instance deadlocks. So basically, if you have a single instance database, you always know that you can have deadlocks when two sessions are locking resources required by each other. So here I want to demonstrate when the two sessions are on different instance of a RAC cluster and a deadlock can still be created. So I'm connected to each instance specifically. If you look at my previous videos, I've demonstrated how I've created custom services PRD apps 1 and PRD apps 2 such that the services will only run on one instance at any time. For example, if I will show you, so my PDB runs on both instances. New test PDB runs on both instances for a different pluggable database. PRD apps 1 runs only on instance 1 and PRD apps 2 runs only on instance 2. If an instance goes down, you would have to relocate the service. So right now PRD apps 1 here. So PRD apps 1 is connected to server 1 RACDB 1, and this is connected to the other instance in the cluster. So first I'm going to create a table. I'll create two tables. You can have a deadlock within a single table also, but for simplicity I'll use a deadlock scenario with two tables. So I can see the tables here. Okay, so I've created the tables from instance 1, but I can see the tables on instance 2. Now I'm going to insert some rows. I'll put into the other table. So I've inserted these two rows from instance 1, but if I were to query from instance 2, I still can't see those rows because the data has not been committed yet. Once I commit, I can view those rows from the other instance of the cluster. So we are all fine here. Now I'm going to insert into the same tables from the second instance. And if I were to query from instance 1 SRV1, I can't see those rows. The new rows inserted by instance 2 until and unless I commit. So now let's view those rows. So all is fine. We have two tables and each instance has inserted one row into each table. Now let's create a deadlock scenario. sorry. So far there is no issue. I can't see that update yet at the other instance, which is fine. I will update the same table but a different row. So if I were to query the table at instance 1, I can see row 1 has been updated, and if I were to query the table at instance 2, I can see row 2 has been updated. So instance 1 has updated this row and you can see it. Instance 2 has updated the second row and you can see it, but they cannot see each other's updates because the updates are not yet committed. So the updates are locked. Those rows are locked. Row 1 is locked by instance 1. Row 2 is locked by instance 2. Now I go in and try to update and if I were to view row 2 T2, I can see that he has updated it. And if I were to view that table from instance 2, I can see. So in T1, row 1 is updated by survey 1 and row 2 is updated by survey 2. In T2, row 2 is updated by survey 1 and row 1 is updated by survey 2. It's all fine. So now if I want to go and do another update, remember, so this row is locked by instance 1 and this row is locked by instance 2, instance 1 again, right? So if I were to try to update, let me just query T1. Okay, so T1, this is updated and locked. I want to update the second row. So what is going to happen here? From T1, this row is actually locked by server 2. So if I were to issue this update, it starts waiting. Okay, and you could actually run a query to look at the blocking session. If I will, let me try that here. Let me just see if I can query the blocking session here. I don't need to go in SSDB, but it's fine. Select. So I can look for blocking instance here, blocking session. So 219.151.447 is my local session here. So it says local session for this user is 219.51447 and that is blocked by instance 2, blocking session 219. We get the same session number also, which is nice. If I want to check that, I can check that as well. Sorry. So I'm on instance 2, right? Sorry. Okay, I'm on instance 2, so I'm just going to run the same sort of queries here for that user. 219. So that's correct. So session 219 in instance 2 is blocking session 219 in 51. This just happens to be coincidence. The SID is the same because I don't have many sessions existing in my environment. But you can see 219 instance 2 is blocking this user at 219 instance 1. If I were to query for the blocker here, it is not blocked. So this session here has a lock on ID called 2 in table T1 but is not blocked. Now let me try to update a table. Okay. Yeah, let's just call it UPD2. So in table T2, ID call 2 is actually updated and locked by the session from instance 1, SRV1. So this update statement that has been run is not visible. Sorry, where is this? Yeah, is not visible to this user here, right? So if I were to update it here, if in the meantime I try to query for blocking session, you can see 219 was blocking my update, and now this blocker has been returned an error, deadlock detected while waiting for resource. So if I were to check whether he is being blocked anymore, no, he's not been blocked because his action has been rolled back. If I were to try to query, so my transaction has been rolled back. Now let's look for the trace file. Since the deadlock occurred here in server 1, I mean this error message occurred in server 1, let's look for the trace file. I can ignore these errors because my standby is not up. I should have brought up my standby. Okay, so here it is. There's a deadlock error here. Now this deadlock error is different. Where is it gone? This is a global enqueue deadlock error. So if you have a local you have a single instance deadlock, you have a different message in your trace file. but this is a cross instance deadlock. So we have a global IQ services deadlock detected, and let's look at the trace file now. There's a lot of information here which is unfortunately too much to read. But you can see here is your global IQ. Your victim is instance 1, which is correct. This is the this is the session which was the victim, and this is the statement which he had run. Let me see if I can scroll up. Right, update T1 set data call where ID call is equal to 2. Yep, this is the session that got terminated. Okay, and he's waiting for a lock. You can actually see that here also in the trace file. So let me just scroll up further to the trace file. Yep. So this is the current SQL of this session. This is the current SQL of the victim session. And let's see, we can waiting for lock. And this is the other guy, server 2. Correct? This is the one that failed in my SQL session. This is the just because I'm doing a VI, it doesn't show the full screen. This is the one that failed from server 1 on the deadlock because there was a lock held by server 2, and this is your lock coordinator. So if you have a deadlock on a single instance environment, your trace file is very different. If you have a deadlock in a RAC environment, your trace file is much more complicated. But fortunately, because I've used SQL Plus, it's very easy to identify which was the session that is the victim here, SQL Plus on server 1, which was the session which was the lock holder on server 2. So let me exit from here. Okay, so T1, I tried to update T1, but my update has gone out. But can I see T2? Okay, so my row 2 update is still valid. And now this per session is waiting. Why is this session waiting? Because he is waiting on a lock held by T1. Let's see this row, right? So I could not update T1 row 2, but I had updated T2 row 2, and now this guy cannot update T2 row 2. If I were to commit, so in this case, so my update has gone through. Now let me just query T2 and let me query T1. So this is correct. And this is status for T2. Let's see if this is why is this the case? Why is this different for T2? Row 2 still shows server 1 here, because although I've done an update, I have not committed. And let me see T1 here. So T1 is fine. There's no problems with T1. Each person's updates are on different rows, but this one is an issue here. Of course, T1 this row was updated here, but it's not visible. T1 this row was updated by server 2, but it's not visible on server 1 because server 2 has not yet committed. So if you have a deadlock, first thing, the one of the two sessions will be written an error. Your trace file in that will tell you which session what was and who was the blocker, who was the waiter. So let's look at the trace file again. But very important, it is only that statement that has failed. The session does not get killed. This session from server 1 was the victim. This session from server 2 was a holder, but it is only the statement that is failed. So if I were to, I was able to commit my other update. Remember, this update did get sorry, which T2, correct. Even I am confusing myself. This update did get committed, T1. T1 row 1 was updated by server 1. That commit went through. It is only the second update statement for row 2 that failed. So if I were to now issue an commit here, see, this has changed. It was now now you can see that both the rows have been updated by server 2. And here both the rows are updated by T1, server 1. So it is very important to remember, when you have a cross instance deadlock, you have trace file is different, only that statement is failed, but any other statements that were there are still available. Sorry, yeah, are still available and can still be committed. Very important.